self-driving cars. They promise us this incredible, safer future. But really, that whole promise? It all hangs on one single question. Can we actually trust an AI with our lives? We're often just told to have faith in its complex learning. But, faith isn't going to cut it when you're going 70 miles an hour. So what if we could replace that faith with absolute certainty? What if we could use pure mathematics to build this kind of unbreachable safety shield around the AI, making accidents a mathematical impossibility? I mean, just look at this. High speeds, cars everywhere, decisions happening every single millisecond. The real challenge here is that these AIs, they learn in ways that are so complex, we can't fully peek inside and see how they're thinking. Their decision-making process is basically a black box. We see what goes in, we see what comes out, but the why behind it, that can be a total mystery. So how can we possibly guarantee safety when we can't predict every single move that AI is going to make? And that right there is the central dilemma. We want to use the incredible, almost superhuman power of AI to drive our cars, but we absolutely cannot, under any circumstances, compromise on safety. It's this classic showdown between raw power and predictability. And on the road, predictability has to win. Every single time. Yeah, that's the multi-billion-dollar question, isn't it? With an AI that learns from millions of miles of driving data, how do you prove it'll be safe in every possible situation, especially the weird, unexpected ones it's never seen before? It's practically impossible. So if we can't prove the AI itself is perfect, what's the alternative? Do we just give up on the whole idea? Or is there another way to think about this? Well, the solution starts by setting one simple, non-negotiable rule. This isn't a guideline, it's not a goal to shoot for. It's an absolute ironclad law that the entire system has to obey, no matter what. No collisions, period. That simple, powerful requirement becomes the bedrock for a totally new way of looking at autonomous safety. So here's the big idea. If we can't make the AI driver itself perfectly predictable, what if we just build a safety net around it? A much simpler, totally predictable system that acts like a watchdog, or even better, like a mathematical guardian angel, making sure that the main AI can never, ever make a catastrophic mistake. And we call this the safety controller. Now, this controller doesn't need to know how to navigate rush hour traffic or find the fastest route to your destination. Its job is way simpler, but it's also way more important. It only has to do one thing: recognize a dangerous situation based on proven physics and step in to prevent a crash. You can think of it like the AI's conscience, but a conscience that runs on pure, cold, verifiable logic. Okay, so how does this relationship actually work? This diagram shows it perfectly. You've got the AI, the complex driving brain, at the wheel. It sees the road and says, hey, I want to accelerate and pass this car. But that command doesn't go straight to the engine. No, first it goes to our safety controller for approval. The controller just checks that action against its simple safety rules. If it's safe, green light, the action is executed. If it's not safe, the command is blocked and the controller takes over to keep everyone safe. So how does this guardian angel make those lightning-fast decisions? It's not using intuition. It's not using experience. It's using a very specific, carefully crafted formula designed to calculate the absolute minimum safe distance you need between two cars at any given moment. Let's break this down, because it's actually just common sense physics that any good driver kind of knows instinctively. The formula, which is called Responsibility Sensitive Safety, or RSS, looks at four key things. 1, your reaction time. 2, the worst-case scenario where you might actually speed up for a split second before you brake. 3, how much road your car needs to come to a full stop. And 4, it compares all that to the absolute fastest stopping distance of the car in front of you. It's just physics. And here's the formula itself. Whoa, okay, don't let your eyes glaze over. You do not need to understand every single symbol here. The key takeaway is that this isn't magic, it's math. Each piece of this equation represents one of those common sense ideas we just talked about: reaction time, acceleration, braking. It's a mathematical recipe for safety that defines a safe world the car is never allowed to leave. So, and this is the really cool part. The controller's decision is always binary. It is always black or white. If the real-world distance between the cars is greater than the calculated safe distance, the AI's command goes through. Simple. But if it's even 1 centimeter less, the controller instantly overrides the AI and hits the brakes. There is no gray area. Safety is mathematically guaranteed. Now, a beautiful formula is one thing, but the real world, well, the real world is messy, it's chaotic. So the big question is, does this mathematical shield actually hold up when things get crazy? Well, the researchers decided to put it to the ultimate test. And to do that, they use this powerful two-pronged attack. First, a formal proof, which is using pure math to prove that the system can never break its own safety rules. And second, they used aggressive simulation, where they basically unleashed it into a virtual world to see how it would handle complete and utter chaos. Now, to really push the limits, they didn't just test it with a normal AI. They created what's called an adversarial agent. This is an AI that was specifically programmed to be aggressive, to be reckless, and to actively try and cause a crash. It's the ultimate bad driver, designed for the sole purpose of breaking the safety system. And this chart basically says it all. On its own, the bad driver AI was crashing all the time, about once every 7 kilometers. But when that exact same reckless AI was supervised by the mathematical safety shield, it had 0 accidents. Not fewer, not almost none, 0. The guardian angel did its job perfectly. And this chart gives us a peek behind the curtain at exactly why the shield had to step in so often. The rogue AI was constantly trying to pull dangerous stunts, accelerating too fast, making unsafe lane changes, tailgating like a maniac. The safety shield caught every single one of these bad moves before they could ever lead to a collision. So this is an incredibly promising approach. It suggests we really can have the best of both worlds, the smarts of a complex AI for smooth, efficient driving, with the guaranteed safety of simple, verifiable math. But, and you knew there was a but, we're not quite at the finish line just yet. Yeah, it's really important to be realistic here. This mathematical shield is a huge leap forward, but it's not a silver bullet. The current model assumes the car has perfect sensors, it assumes ideal weather, and it's mostly designed for predictable highway driving. The real world, with its chaotic city streets, unpredictable pedestrians, and slick, icy roads, that's a much bigger challenge. And extending this mathematical certainty to cover all of that stuff is the next great frontier. Which brings us right back to where we started. This research shows that we can use math to create a provably safe system, at least within certain limits. We can actually have proof. But the final hurdle, it might not be technical at all. It might be human. What will it actually take for us as passengers and pedestrians to truly, genuinely place our trust in the machine?